Hello everyone, I am Mrs. Padmashri from SNS College of Engineering, Coimbatore. Today, we are going to discuss about the reinforcement learning in machine learning subject. So what is reinforcement learning? Which is learn from mistakes. The machine is going to learn from the past experience. This is called reinforcement learning. So, reinforcement learning mainly works on feedback based process. So, what is a feedback based process? Where there is a two process in which the process 2 get the output from the process 1. So, the output of the process 1 again we are going to send as a input to process 2, and again the output of the process 2 we are going to send as an input to the process 3. It follows same. So the feedback process is an AI agent automatically explore its surrounding by hitting and trial and taking the action or taking the decision, learning from the past experience and also improving its performance. So the agent gets rewarded. Whatever the action the agent is doing, we are going to reward the agent like for good action, and if action is not good, the agent get punished for each bad action. So the main goal of the reinforcement learning is to maximize the rewards. So it is basically works on a feedback process, which means any process, if you take any two process, one output is given as an input to the other process is a feedback process, and the reinforcement learning is nothing but the machine is learning from the past experience. So it comes under the supervised learning. We all know there is a no label data. There is no label data like supervised learning, and agent learns from only the experience. For example, we can tell the example like a child learning from the previous experience in the day-to-day life. Okay, this we can take it as an example. So sometimes we used to tell a child, "Don't do like this, don't do some actions," but the children won't listen those commands. So what they will do, they will make a trial, then they will understand what is the problem, then for the next time they will not repeat those actions. The same is applicable for the machine also. If the action of the machine is bad, so next time what we will do, we need to train the machine so that it has to experience with the past data, and the machine has to give the exact output. So the bad actions should not repeat. So this is the agent communication. So this is being used in the reinforcement learning. So and the agent receives the punishment and the rewards as well as a feedback. And a small diagram, this represents the reinforcement learning, the agent environment interaction in a Markov decision process. So as I explained already, this box represent the agent and this represent the environment. See, you can see here the output of the agent, that you can say any action is given as an input to the environment, in which we are going to analyze whether the action is a good or bad. If the action is a good, that is, we can say it the action can be rewarded and it moves to the next state. Suppose if the action is bad, so we are not going to consider that action, we will just ignore it and we will just again continue with the good. So the cycle continues only with the good action. So this is what the main goal of the reinforcement learning from the past experience, that also whichever the experience is good, only that experience we will be considering, and the past experience will not be repeated in the cycle, will not be repeated in the cycle. Here we can see the action is going to the environment, where there are two outputs generated from the environment, ri plus 1 and si plus 1. R is the reward and s is a state. So it goes to the second state only if the action is rewarded. Otherwise we are not going to proceed with the next state. The state will be stopped abruptly, and if the action is good, we are going to continue. We are giving as a feedback to the agent. Again, agent produce some other different action. Again, it is giving as an output to agent's output is given as an input to the environment. So this cycle continues. So this is a small mark of decision process which explains about reinforcement learning. There are two types of reinforcement learning, mainly categorized into positive reinforcement learning and negative reinforcement learning. So what is a positive reinforcement learning? From the name we can say it is towards a positive action. Only the decision is good, the action is good. That action alone will be considered by your machines, by the machine for learning purpose. Is a positive reinforcement. That is, we can say it enhances the strength of the behavior. If we want to discuss with the example, what is a positive? Suppose we are instructing our children, if you complete your homework, I'll give you the chocolate. Which is, the child has to complete the homework, so we'll be giving a reward, like chocolate is a reward to the child. So this is a way positive reinforcement learning is also working. This also can be delivered in the different way, like if you complete your homework, then otherwise you will get scoldings from your teacher. So this is the way, like the thing that we are going to say is you have to complete the homework, but otherwise the teacher will scold. So that statements is a negative statement. So that comes under the negative reinforcement learning. So there are two types, as I said. If we give a reward to the child for completing the homework, is a positive way, is a positive reinforcement. Suppose we are not giving anything, we are not going to give any reward. Instead we are telling, like, if you did not complete your homework, your teacher will scold you. Okay, is a negative statement. So that is a negative reinforcement learning. So this is the one simple example to understand what is a positive reinforcement and what is a negative reinforcement learning. So positive is it enhances the strength of the behavior of the agent and it positively impacts it. The negative reinforcement learning is just the opposite of the positive reinforcement learning, which works exactly opposite, and it increases the tendency of the behavior, and which tells you that would occur again by avoiding the negative condition. Exactly opposite to the positive reinforcement. So this is the two types where the same approach is being applied to the machines also. So we can train a machine in a positive way also, and also we can train a machine in the negative way also. So the main goal of the reinforcement learning is that you're going to train your machine in a positive way, because it is a reinforcement learning, which is called a learning from the past experience. Even the humans also will make mistakes in a day-to-day life. So what we will do, like next time, okay, when this kind of situation arises, we should not repeat the same which we do last time. So what we are just correcting ourselves, right? We are just correcting ourselves, like we won't repeat the same in the next time. The same, machines also will learn from the past experience. Like for example, we can say anything like chat gpt. So whatever the data that we are going to give to the chat gpt, that only we are going to we are training the machine. So next time when we ask any questions to the chat gpt, it is going to give you the answer. If our questions, or if our data is we are going to load it in a different way, or the machine is not understanding proper, it is going to give you the different answer. So the machine also is the chat gpt. We can take as a very good example for reinforcement learning, in which we are going to train the machine with the with the past datas like chat gpt. We are going to load all the data, necessary data, and whenever we need, we are going to ask the chat gpt, and we are going to get the answer from the chat gpt. So the chat gpt is also in a learning process. It's in a learning process. So this is a concept of reinforcement learning. Mainly it works on positive and negative reinforcement. So as I already explained with the example how to practice the reinforcement learning with kids, make one example for the positive. We can say making their favorite dish after they finish homework. Like we can say, like if you complete your work, I'll prepare noodles for you. So this is a positive way of doing reinforcement with the kids. Suppose the same, if you want to understand about the negative, doing your homework on time to save your television privilege. So this is one way of negative, like eating healthy to avoid falling sick. One way of negative reinforcement with the kid, how to practice the reinforcement learning with the kids. So this is an example of just to understand what is a positive and negative reinforcement learning. So reinforcement learning, there are different use cases available. I just want to discuss about the some few types of use cases in the reinforcement learning. One is a video game, like always the gaming, learning from the past experience. Like as I already explained in my first chess game. If you take a chess game is mainly learning from the experience. If you do any movement, the movement will be registered. So next time, in order to improve the performance of the game process, the machine will understand from the past experience. So if we move like this, we will be rewarded. So the same video games also comes under the reinforcement learning. Example, we can take it as a chess games also, resource management, robotics, text mining. These are all the different use cases in the reinforcement learning. Here there is a difference for the supervised learning and unsupervised learning based on the category of training, the data, task, learning approach, and some of the examples I have displayed here. The training data for supervised, it requires a labeled data with output, but unsupervised work with the unlabeled data. And the task wise, if we categorize, prediction or classification comes under the supervised, and the clustering or dimensionality comes under unsupervised. Some of the example, we can say linear regression, logistic regression is in supervised. K means clustering and hierarchical is in unsupervised. Decision trees and support vector machines in supervised learning algorithm, and PCA, principal component analysis, which is coming under the unsupervised learning. So the reinforcement, which is like it comes under the supervised, we can say. Some of the applications of machine learning is widely it is used in many area. We can say intelligent agents, natural language processing. We are using social medias where Instagram, Facebook, Twitter, we are using currently all this machine learning application. Transport also, financial services, healthcare, e-commerce, etc. Okay. So the last, I would like to explain with the users of machine learning. As I explained already, all this reinforcement learning, positive reinforcement, negative reinforcement learning, supervised and unsupervised, we are using it various applications in machine learning and various users of machine learning. There are Snapchat. If you see, many will be having the Snapchat. So Snapchat is one of the example, like we can take it for as a uses of machine learning. Instagram, Facebook, Google, LinkedIn, etc. So these are the various uses of machine learning. Thank you.